Hello, sir. How are you doing today?
You don't have to refer to me as sir. Shagun is good, and yes, I'm doing fine. I'm doing fine. How are you?
All good. All right. So, welcome everyone to the next podcast in the Offbeat podcast series brought to you by onRec IIT Roorkee, the official podcasting club of IIT Roorkee. Our today's guest is a Roorkee alum of the 2015 batch, Mr. Shagun Sodhani. He's a computer science graduate who has worked in companies like Adobe and Microsoft and is currently a research engineer at MetaAI. He did his master's in artificial intelligence from the University of Montreal in 2017. We're glad you could join us today, Shagun.
Glad to be here.
All right, so let's kick off our today's podcast with the very first question. Shagun, can you walk us through your 4 years of at IITR in brief, like especially the transformation in your mindset from the Shagun who got into IITR in 2011 to the one who graduated in 2015?
Yeah, there were a lot of things that changed. I signed up for the computer science program and I did not know how to program. And when I say I did not know how to program, I mean I did not know things like how C++ works. So I think the first 6 to 8 months were somewhat difficult in the sense that, hey, I'm in this program, I'm with this bunch of people and I don't even know programming, and I'm not even sure if I like programming. So in fact, I think for the first 1 year or so, I thought I can get out of the I mean, I can get through the program without actually having to do things like understanding algorithms, and just by doing, for example, like building stuff. And this was the kind of mindset I was in. And obviously, by the time I graduated, things changed a lot. I enjoy algorithms. I enjoy data structures a lot now. So that was one big change. The other change was, I think this is applicable for a lot of us. This was my first time outside home and sort of building and finding a family outside the immediate family that we have. There were some good experiences. There were bad experiences. Overall, the journey was fun. Um, I think the other thing that changed is I was a lot less confident when I got into the IIT, because hey, this is the first time you're going outside. You don't know how the outside world is. And by the time I came out, I was a lot more confident about myself, about that I can deliver things, I can do things. So that was another big transformation that happened, and I'm sure a lot of people go through the same thing. It's not unique to me.
All right, so you talk about like how you've transformed in a lot of different categories. You would have explored a lot of fields while you were in college. So my question to you is, how did you end up fixing data science and artificial intelligence to some extent? Since back then in 2015, if we talk about, or even during 2011 to 15, it wasn't a very trendy field back then. So what was your journey, especially with the exploration of fields, look like?
Yeah, I tried a bunch of things and I failed in most of those things. And to just give a brief sense of what are the things I tried making Android apps. I failed at it. I tried making web apps. It was okay. I tried things like back in the day, there's, or probably there still exists, this operating system called as Barrelfish by Microsoft. It's a distributed operating system. So I think in our second year, we started doing a project around that. Obviously, we were grossly underqualified for doing something like that. The point is, I always thought that I want to try as many things as I can, and I want to fail as often as I can, because there's no cost of failing, or at least the cost of failing in an undergrad program is much lower than the cost of failing in the real world. And I don't think I was fixated on data science when I was graduating. It definitely looked interesting, but it wasn't, I didn't have this calling as to, hey, I must be doing this thing. Part of the reason I got more sort of interested into this is the first team that I joined in Adobe was it was a analytics team or a big data team. I don't recall the official name of that. And they were doing a lot of data science work and big data systems and scalable systems and so on. And there were a lot of smart engineers in that team, and interacting with them gave me a sense of how vast the field is and how much scope for creativity there is. And creativity in terms of, hey, this is a problem, this is the end goal, figure out a way to enable this in this set of constraints. Yeah, so it wasn't, definitely not a linear journey. It wasn't like, I woke up one day, did a course on Coursera, and all of a sudden I've fallen in love with this area. That was not the case. I tried a lot of things. I failed at a lot of things. And by the time I think I came to ML and data science, I was sure that I've tried sufficient number of things to know that this is where I can stick around for longer.
All right. So, matlab, you would obviously have had some period of time where you would have felt very low. So, like, especially in a field like, for example, after you interned with Adobe, you got to know that, all right, data science has something interesting for me. So, even after that point in time, you would have had some low of yours. I just want to know, how did you recover from that low? That considering that, all right, you're reaching towards a point in time where you need to prepare for placements. So you need to have a particular role in mind. So what was that point? How did you recover from that point?
Yeah, I mean, I was lucky in terms of placements that I did not have to worry about it. Adobe was kind enough to give us a pre-placement offer. In fact, it meant that even if you want, you cannot sit through the placement. So I did not have to go through that hassle. But obviously, there have been low points, both in the academic life, and for example, in the undergrad days, in the days of doing masters. I think one particular low point was I had submitted a paper to a conference and it got desk rejected, and desk rejected not for formatting errors. It's like it means sort of, your work is basically not even aligned with what the conference is about. I think that was a particularly big low point. Um, yeah, I mean, there's no specific strategy for coping with these things. What helps me at least is you talk to more people and you realize that this is not a unique experience for you. So knowing that, hey, other people also get their papers rejected in this kind of a way doesn't really mean that you're a bad researcher. It just means that particular work that you submitted is not appreciated, or is not probably it's not good enough. So experiencing these kind of things and sharing this experience with others, it helps to normalize the experience. So that was definitely one thing that helped. My supervisor said that, look, you cannot fall beyond this, right? Like, what else can happen? I mean, submitted a paper, it got desk rejected. What's the worst that can happen? So you're basically, it's like, you've seen the worst and everything else is going to be better from there on. But I think the immediate few days after that were pretty bad, and I wasn't sure if I want to keep doing this or not. But I think the main thing is you share your experience with others. You realize that this is not a unique situation for you, and very often it's a matter of just sticking into it. It's like, okay, I'm just gonna be here for the next 5 days, and the feeling of being low, the feeling of rejection, the feeling of dejection would sort of normalize.
All right, that's something great that you've given us. Like at least to like sit back and relax and like at least give yourself some time and talk to people. Like let's normalize stuff like that. Like this stuff happens and we need to accept and move on. All right, let's go back in time and like how was your work experience in Adobe? Like you mentioned that you had a very good team around you. So when was it time that you realized that all right, should you pursue this? Like what was that aha moment of yours, if there was any, during your work at Adobe?
Yeah, I mean, the aha moment was more along the lines that I was very lucky to join Adobe at a time when they were working on this big project, where it was a new thing for a lot of people in the company. So the people who were driving that effort, they were by no means experts in data science, but they were all strong engineers. They knew their stuff, and they were basically trying to figure out how to use their engineering expertise to make a big data engine of some sort. A couple of things stood out. One was, hey, there's this bunch of smart people. They don't understand the problem in the sense of, hey, what's the data science part of it? But they are smart enough and they are good enough programmers that they can jump into this problem and sort it out. So for me, that one of the realizations that came out was you don't have to be an expert in everything. And obviously we all know this, like we don't have to be an expert in everything when we start, but the effect is much stronger when you actually see people doing this in front of you instead of just being told by someone that, look, you do not need to be an expert to start doing something. The other thing that stood out was you need to build one muscle, but that muscle needs to be very strong. So for those people, the muscle was basically being extremely good programmers, and they knew how to think about systems. And even though they had never thought about a system like the one they were trying to build, they were easily able to sort of apply their thought process from one problem to the other. And the takeaway for me was, instead of there are two ways of building your expertise. One is you know a little about a lot of things, or you know a lot about one thing. But then there's a third form, which is more like a T shape, where you know a little about a lot of things, and then you know a lot about one thing. I always used to think of learning more like, it's either a breadth first thing or a depth first thing. And interacting with those engineers, working with those engineers, made me realize that there's a T-shaped thing as well, where you could be good at a lot of things. You could be not good at a lot of things. You could just know a little about a lot of things, but there could be one thing that you're expert in, and that's probably the mode of operation that works for a lot of people, and that works for me as well. So I think one of the things that pushed me towards sort of start focusing on one specific thing was this T realization, where you don't have to choose breadth or depth. You can have a good combination between these two things. I think the other things that I learned from that time was, there's this opportunity in the sense that you could be exceptionally good, and if you don't get the right opportunity, in a sense, the talent could be wasted, right? So it's not enough to be talented, you also have to be at lookout for opportunities. And sometimes we just think, at least as engineers, we like to think that my work would speak for myself. And as long as I'm doing my work properly and the work is good, people would come to you and they would recognize your work. That's not how it works. You need to go out of your way to make sure people know about your work, and you need to go out of your way to find opportunities where you can either learn new things or excel at what you are doing. So those were some of the realizations that came at that time, and they have been helpful all this while.
All right, that was nice. I think so. We've learned a lot about how you need to keep moving on, and like you'll have something or the other realizing, like you'll realize something during your path at like working or whatever you're doing. So when did you realize that, all right, you need to get a master's degree? And like a general question for all of the viewers who are asking us, like what is the best time that one should apply for a master's? Like, is it straight after B.Tech, or should they get some work experience, like say 2 or 3 years like you had? So, what is an ideal route according to you?
Yeah, I like to answer this question in terms of, you need to look into yourself and see what exactly it is that you want, and I'll make it more concrete. If you want, I'm just taking instances. I'm not saying this is what people actually want, but for example, if your goal is to have a very fast sort of progression in your career in terms of climbing the ladder, then doing a master's right after B.Tech makes more sense. And I'll go into this within a minute as to why that is the case. But if you are more of those people, like, I just want to work on more interesting problems, and I'm okay, for example, waiting for a few years for my next promotion and so on, then it's probably better to work in the industry after your B.Tech and then decide whether you want to go for a master's or not. Now, coming to the first thing as to why did I say it's better if you want to climb the ladders faster is, at least in US, your B.Tech, the work experience after B.Tech generally does not count unless it's a elongated period. But let's say you just do a 2 year or a 1 year stint in the industry, and then you do your master's, and then you go to US, for example. Very often the companies would discount your work experience, and they would basically have you start from the starting level in the company. And so in that sense, you have in a way lost out 1 or 2 years of work experience that if you had applied in the same company or you had been working in the same company, you would probably have climbed the ladder. But that's a very myopic view. But I just want to put it out, because if this is what people want to optimize for, this is one way to look at it. My understanding and my preference is that it's better to optimize for the long run. And so working in the industry right after your B.Tech, it helps you understand a few things. It helps you understand how to operate, how to collaborate with people, how to have reasonable work-life balance. And it also helps you figure out whether you really want to do or pursue higher education or not. And I also want to sort of dispel this, that you do not necessarily need a higher degree to excel in a field or to excel in a new field or a field which is sort of not well defined. Having a degree is one way of showing that, for example, you know how to do research, but that's not the only way. There are many other ways of showing that you can operate in a new domain without necessarily having a degree in that domain. The third aspect that people should be careful of is, if you spend too much time in the industry, it becomes harder to get back to academia, simply because, again, you're climbing the ladder, life is good, you're making good money. Whereas once you're back to being a grad student, the work-life balance is somewhat worse. Obviously, you're leaving some money on the table. So there's a fine balance, and I think that probably 2 to 3 years is a good time for you to gain some experience in the industry, understand how things work, understand how to collaborate with people, how to set reasonable boundaries, both in collaboration in your work-life balance, and then go back to grad school. And because when you come back to grad school after some work experience, you start to look at things in a different light. It's not all about, hey, I just need to clear these courses and write this paper and get out. No, then you start investing into building meaningful relationships, which are helpful in the longer run.
All right. So, matlab, is there any sort of checklist that a student can have a point in time? Like, for example, when does it, like, are there certain parameters that a student should mentally retrospect as to when he or she is ready to get a master's degree?
Yeah, one of the things for me was, if I keep working in this place, what is the next big thing that I would be doing? And the nature of places, and this applies to a lot of workplaces, is when you start in a new place. In fact, it applies to pretty much all the places. When you start in a new place, there's a lot for you to learn, and in terms of the culture, in terms of the tools that they are using, in terms of the way they work, in terms of, hey, this is how I don't know, we make things. This is how we make things. So there's a lot for you to learn. And over time, the incremental learning that is happening, that keeps diminishing. And it's, which is obvious, right? Like you would not be learning as much as you were learning on day one as on, let's say, after spending 5 years in the same company. So because you already have known these things. So one indicator or one sort of barometer that I use is, hey, I'm in this place for N number of years. Am I learning something new or not? And I would not think of it in terms of, hey, do I want to go back to academia or not? It's an isolated decision. It's like, am I learning enough at this place or not? And if for some reason I feel I'm not, or at least not to the extent that I want to learn, then I start thinking about, hey, what are the other things that I can do? So for me, it's not a decision between academia versus industry. It's more like, wherever I am I learning enough or not? And if I'm not, then let's see what are the other options outside. And that's how it worked at the time of Adobe as well.
Oh, all right. That's a very nice perspective of yours. Just coming to some general questions again, like what benefits does having a master's in DSAI provide, it with respect to the job or the career perspective, over a bachelor's in deep learning or a bachelor's in DSAI? Like obviously a master's will has a lot of value attached, but with the job or the career perspective, is there a huge jump? Is there a huge change?
No, not just in the terms of degree. In fact, as I was saying, right, in US, if you go there after doing a B.Tech versus versus an M.Tech or an MS, you're treated at the same. I mean, you start at the same position, right? And at least in the big companies, you do not get a benefit just because you have a M.Tech or a master's. You obviously get benefit because of the work that you have done during your master's, let's say, but that's because of the work and not because you have an extra degree. In some cases, in immigration related scenarios, you may get a benefit, specifically if you're applying from the same country where you got a master's or a PhD. So that definitely happens. So let's break it down. What are the benefits of going from B.Tech to MS and MS to PhD? Going from MS to PhD definitely opens a lot more doors for you. But again, that's because you have done, you have 5 years and you would have done some interesting work. And the thing that is opening the doors for you is that interesting thing. But going from B.Tech to masters, and usually people try to wrap up their masters in 1.5 years or sometimes even 1 year. It's just not enough time to do research work. And the bottom line is, if your research profile, for example, does not look very different after B.Tech versus MS, it's not going to open a lot more opportunities for you. So what matters more is what kind of work you have done versus, hey, I did this degree versus this person has not. Am I going to? Yeah, probably not that much. You probably won't get that much of a benefit.
All right. I think so. A lot of our viewers should take note of the fact that once you're going for a job after a bachelor's or your master's, you're considered at the same level to some extent, even though you have
Unless,
another degree.
yeah, I mean, obviously there are exceptions. Like you could have multiple offers and then you can negotiate it. What I'm saying is, if you had just one company that you're interviewing with, and for example, you did B.Tech, let's say 1.5 years in industry and then in MS, and let's say your MS was in US, then yeah, you would very likely be getting the same position that a person right after their B.Tech would have got. Obviously, you can negotiate around it. You can have multiple offers, and then it's a different ball game altogether.
Right. Understandable. Totally understandable. All right. So my next question to you would be like, which type of a format of a master's degree should one choose? Like, there is a research-based master's format, degree format, and a course-based. So, what is your suggestion for students who are confused as to based on this question?
Yeah, it goes back to, again, what exactly do you want, right? If you want to be in a research role, then obviously you should opt for a research degree. In some cases, people want to use masters as a way to get to US, and I fully support that. And in that case, people should sign up for a program which they can finish as quickly as possible, because their motivation is to get a work authorization in US. So it really boils down to what you want. And this is one thing that I often see in students. They are not sure what they want, or maybe they feel that they would be judged if they explicitly say, hey, this is exactly what we want in life. I think they should not worry about this. They should be very clear, hey, I'm doing this thing because of XYZ. Maybe XYZ is because you want to make more money. Maybe XYZ is because you want to do research. Maybe XYZ is because you want to settle in US. It's all fine. Like, just be clear on what your end goal is. No one should be judging you for that. And if someone is judging you, like, skip them, like, don't worry about them. But basically figure out why exactly are you doing that, and then optimize for that. So if, for example, your end goal is to get hired in US, and then you don't really care about whether it's a research job or not, then don't do a research master's, because you're putting yourself through a lot of extra work for the same thing that you could have gotten much easily. On the other hand, if you want to be working in a research lab, then don't take the shortcut and go to a research master, try to produce some good papers, because that's what's going to help you. Yeah, so I think it's something that people have to sort of look inside and figure out what exactly they want to do, and then they can choose between the two. I even know of cases where people would sign up in research masters and then convert it into a course-based master and sort of wrap up stuff in 1 year and go and work in the industry. And again, that's good because they know what they want to do.
Right.
The troubling scene is where people are not sure what they want to do and they hope someone would be able to answer this question for them, but the answer is very clear. Like, do you want to work in the industry and you don't care about research, then go for the course-based thing. If not, then go for the research-based thing.
All right, I think so. You've cleared that doubt for a lot of our viewers there. All right, our next question is about school selection. So, how does one select the best school for the master's degree, considering there are so many great schools in US, Canada, Europe, and all across the world, and there are so many distinguished professors working in this field. So, what influenced your decision? That's my first question. And then, my second follow-up question would be as to how does one go about making that choice about which school would do more justice to their time and energy.
Yeah, I mean, a bunch of high-level factors. One is how good of a financial position are you in? There are some selected schools in US which would waive off your fees for masters, at least from what I recall. I think UIUC is one of those. I mean, it waives it off in the sense that you get a guaranteed TA, and other schools also offer a TA-ship position. Much less for masters, but for example, I think UIUC is one of those which definitely guarantees you a TA-ship for master students as well. So I think the number one factor for a lot of people is whether they can afford it or not. And if you can get it waived off or there's going to be some TA support guaranteed, then it's a good thing. So people should look into that. I think countries in Europe and Canada often help you get scholarships upfront, which means you don't even need to show proof of funds when you're applying for your visa. So that's another thing that people should look into. The other thing is, then it again goes back to the question of, look, what exactly do you want to do? You want to work in a foreign country. Okay. Do you want to make a lot of money? Well, most of the money in terms of salaries is in US. If you compare the salary of a person in US versus Europe, at the same level, in the same company, the salaries are different and the US salaries would more often than not be higher. So if someone is optimizing for money, then it makes more sense to go to a US-based school as compared to any other school. Then there could be cases where you want to work with a particular person, or there could be a case where hey, I want to work in this subfield in let's say AI/ML, and there's this particular school which is well renowned for that thing, and then you use that as a criteria. To take an example, if you want to work in RL, robotics, and those kind of things, then Berkeley is one nice place, and it could be super expensive, and obviously that's one factor. But then you could also say that, look, this is the place where I want to be, and that becomes a big factor for you. For me, the main thing was I wanted to work at a place where I would have independence. Like, I do not want to be told what I should be working on. And this is something that master students often do not have a lot of freedom, because the professors would look at it as, hey, you have just 1 year to do your research in a research-based master, or probably a semester to do your research. And if there's a lot of freedom, then it's possible that nothing would come out after 1 year, which is a logical thing. So sometimes you would not have, basically you would not have a lot of freedom in figuring out or choosing what things you want to work on. This is one thing I wanted. The other thing for me, I think, was the fact that the opportunity was with Yoshua, which is, like I believe in learning by working with people and by observing them instead of, for example, there are different styles. Like, one style is where you just work with someone or you observe their style, which is the style that I prefer. The other is, hey, I'm going to read papers by this person, or I'm going to, I don't know, look at their work as an outsider and then see how they are thinking about this problem. For me, the first style works, where I see people in action. Even if I'm not part of that action, I see them in action. I see how they're conducting themselves, how they're thinking about a problem. How do they start with a sort of a broad vision and they narrow it down to a concrete set of experiments? That's the thing that works for me. I like learning that way. So that was another big sort of influence for me to figure out whether I want to be at Mila or not. So those were the factors that worked for me. But to start with, again, think about what exactly you want. You want, for example, money, go to US. You are looking for a specific subfield, find the place where those people are who work in that specific problem. For example, multi-agent RL, I think a lot of multi-agent RL happens, or a good work happens in UK. So if that's a thing, or that's an area that you want to focus on, probably UK would be a good place for you to be in. But then, there are other factors that you're completely ignoring.
All right, so pretty subjective decision based on what you want to do, what are your resources, what is your exact plan that you have currently that you've thought of in life. All right, so but building a profile is the base of all of these things. Like, in the end, you need to build a great profile. And while researching more, we saw that you've published a numerous number of papers on data science and artificial intelligence. Can you highlight the importance of writing research papers while building a grade profile for top schools?
Yeah, so writing research papers specifically, it serves 2 or 3 purposes. One is we expect that most of these papers are peer reviewed, which means it's not just you saying, hey, I know how to solve this problem. It's other people also validating it in some sense. I mean, I understand it's a very subjective validation, and by no means is the review process perfect, but it's more than just me saying, hey, I've solved this problem. There are some other people who are in some sense reviewing it and saying, hey, this makes sense or does not make sense. So that's one of the benefits. It gets credibility to your research. The second thing that writing a research paper does is it shows your thought process to someone else. Look, some of these problems, people work on it for years, and then if you have to give a talk and you have to explain everything in an hour, it's just not possible. I mean, sure, you can go over the high level insights and hey, these are the main things that work or that doesn't work. But reading a research paper also gives a view inside how you think about this problem. Because, for example, I could read the introduction and be like, this introduction does not make any sense. I mean, the results are awesome, but this person probably does not have the clarity of thought or the motivation that they are using for solving this problem. It seems to be very specific, and it would probably not work for anything else. So writing papers is another way to show your clarity of thought. The third thing is writing papers is it's a sign that you can do rigorous work. And the reason I use the word rigorous is you would write a paper, it's likely that it would get rejected, and then you will have to either do some more experiments or polish the paper or do something else. And so there's this iterative nature, right? It's not like, hey, I have done this thing and I'm just going to move on with life. No, you understand that the first version that you're writing or building is not perfect, and there are improvements. And then you're one of those people who are willing to put the time in improving things. So this rigor is super useful, and it's very easy to display that through papers. Now, obviously, there are other things that you can do to show this. I'm not saying that writing papers is the only way, but writing papers definitely provides a way to show all these things. Now, this is for the outsiders in the sense that, hey, if an external person reads my paper, these are the values I hope they get. For the person writing the paper, it's useful because it forces you to collect your thought. I could have a grand vision, and this grand vision give me 50 years, and I can keep working on this grand vision. But writing a paper forces me to sort of, stop and be like, look, I have to figure out a milestone, or I have to basically have a self-contained story about, hey, this is the problem that I'm trying to solve. This is how it relates to other things, and forcing yourself to do that. It's a good thing for research, because completely open-ended research without any constraints, you can keep doing it, and without making any progress. So in that sense, it's a good check mark, or it's a good milestone for you to figure out what you're doing, whether that aligns with the long-term vision that you have or not.
All right. So I think so. So what, according to you, are things that a person should do? Like writing research papers is one great thing. Other than that, how can one build a good profile to apply to these top schools or get admissions there? Like, is there any other parameter or a characteristic that a person's profile should have?
Yeah, I mean, my answer would be very biased here, because I applied in the pre-COVID world where things were, the expectations were different. In the post-COVID world, I think the expectations have changed a lot. And to take some concrete examples, when I was applying, there was no way for me to attend conferences remotely. So it's like you write an email to a professor, and if you're lucky, they'll reply. If you're not, then well, it's okay, move on. Whereas now you can attend conferences virtually, and I know it's not as great of an experience as attending a physical conference, but at least for people in India, we did not have this opportunity of attending the conferences, right? Like most of the conferences take place in North America or in Europe. So for us, the fact that conferences are virtual, or at least were virtual to some extent, it was a great, what do you say? It was leveling the playing field to some extent, because now
Right.
you could also reach out to a professor over, in one of the gather towns, or doing these remote workshops and so on. So yeah, I'm not 100% sure if I have the best answer to this, because I did not have to do a lot of networking in the post-COVID era. But yes, I think one of the important things is that research, and knowing research doesn't mean you have to write a lot of papers. It means you understand what's happening in the field, you understand the direction which the field is moving, and you can have a reasonable conversation with a person on a research topic that may not be your primary research topic. And an example of this would be, can you and I have a conversation about, I don't know, stable diffusion? And at least I don't work in stable diffusion, but I can, if you bring up a point, I can understand it, and I can probably add some value to it from the perspective that I'm working in, from the perspective of the fields that I'm working in. So one of those useful skills is know your research. And I'm not saying read every single paper that comes out, but if there are big breakthroughs happening, then you should know about them. You should also have some sense of how that ties into what you are doing. And that doesn't mean you are necessarily using them, but it's like, I don't know, let's say you're doing reinforcement learning, and I'm talking about transformers. And for you cannot see any way in which transformers can be used for your reinforcement learning work. I mean, that's maybe a bit problematic. Again, no one is saying that you have to be able to do it, but you should be able to take ideas from different fields and sort of figure out, hey, this is how these things can be used. You should know about the limitations of your field, and your field is something that you choose. So it's not like, hey, X has this limitation, Y is that limitation. You decide what X or Y is for you, and you should know what are some important problems in your field. Again, you don't necessarily have to work on them, but you at least have to know these are the problems.
Understood.
Yeah, I think the last thing is you should have one muscle. Figure out what your muscle is. And this goes back to the key thing, right? Maybe your muscle is writing papers. Maybe you're very, very good at writing or articulating or making a concrete argument. That's a super skill. That's great. Or maybe your super skill is you can quickly skim through papers and draw connections. You can be like, this paper is doing this thing. There's this other problem that can be solved using an architecture like this. Maybe you can do this kind of connections. That's a superpower. Maybe you're a great coder. Maybe you know how to take crazy systems and implement them or design crazy experiments. So these are all different forms of superpowers, and you should pick at least one of them and build a muscle in that. And once you have muscle in one area, then you can slowly sort of start contributing or start building a muscle in the other areas as well. But yeah, don't spread yourself too much, and don't try to be an expert in all the areas at once. Try to go for a key thing.
All right. So we asked our audience for a lot of questions for you, and the number one question that we received was like, if someone is from a non-CS background and wishes to build a career in deep learning or, for example, data science and artificial intelligence too, what should he or she do? Because like, what is something that you would have in mind that that person could do?
Yeah, there are two kind of opportunities. First of all, I want to sort of counter this myth that you need to know CS for doing deep learning. In fact, a lot of work that we do does not involve direct CS, right? Like we do not often write graph search algorithms. We do not often implement red flag trees. It's not using, and we are not operating at the level of operating system kernels. So it's not that knowing a lot of CS is super critical. It's useful, but it's not super critical. And the good example of this is a lot of people with PhDs in maths and physics are contributing a lot to machine learning systems because there are ideas that you can use from these fields for applying in deep learning. And these people often do not have, they do not even have programming backgrounds. So that's like, they're so much further away from CS in the sense of day-to-day CS that we do. And these people have very successful careers. So it's not that, very successful careers in machine learning. So it's not that you have to know or you have to have advanced degrees in computer science to be able to do that. This is a good thing because a lot of computer science is very hands-on, right? Like, I don't remember all the different kind of interrupts you can have in an OS, but that doesn't stop me from using an OS. It's a hands-on sort of field, and it's very easy to sort of pick up new things here. So that's one way to look at it. The other way is, even for people who have maths and physics, one could argue that, hey, they are still somewhat related to computers. There are things like logic, there are models which are similar. Even for people who are working in fields like biology or material synthesis or chemistry, there's a lot of opportunities. There are a lot of opportunities right now because there are a lot of labs which are working on, for example, synthesizing compounds. And when you work on something like this, you need people who have the domain expertise in, let's say, chemistry or biology, but who understands machine learning as well. So again, it goes back to that thing. Your muscle is chemistry or biology or organics, but then you also have a breadth of knowledge about how machine learning works. And people like this are super valuable and super hard to find. And these people, in some sense, are more valuable than the machine learning people, because right now it's easier to find machine learning people as compared to people who have this intersection of skills.
Understood. So I think so it's very important to build that T type thing and have a lot of, like, you do not necessarily need to be good at a lot of things, but you need to have that muscle in that one particular field.
Yes.
That's something
Yes.
great that we've got from you as of now till date. Thank you so much for that. Can you compare the quality of masters in India versus getting a master's degree from abroad in terms of, say, student environment, quality of work, and opportunity for growth amongst the other parameters?
Yeah, this is somewhat difficult because my master's was a somewhat non-conventional master's. So, it's even difficult for me to compare my master's with Indian masters as compared to, in general, foreign masters. So I'll probably skip that, but I can tell you a bit about how masters works in Mela. Or at least how it used to work when I was doing it. So you have to do 4 courses over 2 years, and we do 6 courses in a semester in IIT. So I mean, obviously those are gradual courses, so it's not the same thing. But 4 courses in 2 years, I mean, you most people reasonably do it within 1 year, and then you have 1 full year for doing research. And this 1 full year for doing research means that you don't necessarily have to, for example, worry about submitting assignments. People sometimes take additional courses because they want to learn, and that's great. But from a course requirement perspective, you have 1 full year where there's no other thing for you to do. Maybe you're teaching a course again that's often out of your own interest, but you have 1 full year for doing research, and that's great. That is amazing. And a lot of at a lot of other places, for example, in US, you would be doing probably 6 to 12 courses over 1.5 to 2 years. And the difference that I see is I would rather have more time for doing research, for doing hands-on research versus taking up courses. So that's one big difference in the way my master's was as compared to other masters, but I wouldn't necessarily say it was definitely better. It's something that I liked. It's a style that I prefer, but it may not work for other people. I just was going through my notes, and I just recalled one more thing. So there was this question, right? Like probably the second last question that you were asking about other people from other fields getting into machine learning. Luckily, there's also this bunch of programs run by different companies where they would invite people who do not necessarily have machine learning experience, but they want to try out machine learning, and they would provide different levels of support. So I'll highlight the ones that I know Meta is running, but I'm sure other companies are doing something along those lines. Residency is something that we all know about, and I'm sure a lot of you are applying for those. But residency is more focused for people who just finished their college, or who probably are, they finished their college within a 1 year time span. There's this other program called as RACE, RAISE. You can Google it, Meta RACE. The idea is that people who have been engineers for some time, but not necessarily machine learning engineers, but they want to understand how machine learning works. They join this program. I think it's a 2 year rotational program, which means you work with a bunch of teams over this period of 2 years. And after 2 years, you sort of figure out if any of these teams is interesting for you, or any of the work that they are doing is interesting for you. And then you interview for a full-time opportunity. And the idea here is that you get exposed to machine learning workflows, you get exposed to machine learning work without necessarily having that background. So there would be a team which would be sort of helping you get ramped up and onboarded and understand how things are working. The level or the barrier of entry is somewhat lower, in the sense that it's not like you have to go to a full machine learning interview without having machine learning expertise. So the interviews would be designed to make sure the machine learning part is de-emphasized, because this is meant for people who do not have machine learning experience. So RAISE is one program. A lot of other companies, including Meta, have this option of short-term employment, where grad students can work with the labs like 20 hours a week or even 40 hours a week. And I understand this is not exactly along the lines of getting started into machine learning, but a lot of these people often tend to be from backgrounds which are not necessarily machine learning backgrounds. So as I was saying, hey, you could be a PhD student doing PhD in maths, and then you start working with an ML team and you start figuring out how you can add value. The big benefit of these programs over internships is they are stretched over a longer period. So it's not that you get into a company and within 3 months you have to figure out how to make impact. Right. Let's say it's a 6-month or a 9-month position. So you can take your time to ramp up. You can also take time to explore the field and get a sense of where your interest lies and how you can add value.
All right, that's interesting. I think so. Thank you so much for listing out those programs for our viewers. I think so it'll help a lot of them who are not sure about, as to, like, a lot of us obviously want to explore fields in a short period of time, and I think so getting on-site exposure is a great thing for all of us. Thank you. So let's jump to the next section, which is career-related questions. So I've heard of roles like research engineer that you're doing, research scientist, etc., etc. If you can help us out, like, with what are different roles in machine learning and deep learning that exist in companies in today's world, and like, could you give us some insight as to what is the work associated with those roles?
Yeah. So let's see. Big disclaimer, different companies use different words to mean the same thing. So what a machine learning engineer means at company one could be called as machine learning developer at another company. So, take all of this with a grain of salt, and do not sort of overfixate on, hey, this person said ML engineer means this, but that's not the case. I mean, this is more like a spectrum, right? So on one end of the spectrum, you have teams which are deploying, and again, when I say spectrum, I don't necessarily mean good or bad. I just mean spectrum of possible things that people work on. So on one end of the spectrum, you would have people who are basically just working on research, which is, hey, there's this problem. We want to find a way to solve this problem. And that's it. And solving the problem in this context would mean, for example, publishing papers or maybe creating artifacts that are used internally, but not necessarily interacting with the product teams, or not, at least not in the short run, they would not be interacting with the product team. So this is where the research roles come in. And again, research has got the spectrum, but on the extreme, you have this open-ended research roles. And as you move along the spectrum, the open-ended part or the broad part of research sort of gets lowered a bit, and then the research starts becoming more and more focused. And on the other extreme, you would have people who are working on solving specific machine learning problems for different kind of products and services. Now, the broad terminology goes this way. You would have a research designation. So you can have research engineers, research scientists, or research software engineers. A research scientist generally tends to be a person who has a PhD, and their work is more along the lines of providing high-level direction to the team in terms of, hey, these are the technologies that are coming up, and we should figure out how these things fit into what we are doing. Often research scientists are not the people who are doing a lot of hands-on work. Again, this is, going back to the disclaimer, it is possible that there are a lot of smart research scientists who are doing a lot of hands-on work, but generally, this is how the terminology goes. So research scientists would not be doing a lot of hands-on work. Their work is more along the lines of figuring out what are the things that the team should be looking into, what are the technological breakthroughs that are happening, or the ones that are likely to happen. Then you have research engineers. Think of research engineers as the hands-on counterpart of research scientists, whose job is basically to build systems, and building systems can mean many different things. Building systems could mean you are writing an open source library for others to use. An example of this would be, for example, the Whistle library from FAIR, which is it's used for self-supervised learning and computer vision. So the team uses it for their own work, but they have also open sources, which means everyone else can use it, and they are actively maintaining that library. So not just open sources, actively maintain it as well. All research engineers could be working on somewhat more shorter-term projects, which is like, hey, I have this curiosity. I want to see whether this works or not. We don't plan to support the system in the same way, for example, Whistle is being supported. We'll open source the code, but we are not going to actively maintain it. And the third sort of profile that you would often see is a research software developer, where the expectation is more that you are playing more of a, even when you're building research systems, you could build research systems in a way that, hey, I want this specific hypothesis to be answered, or we want to have some sort of components that everyone else can work on, even within a research setting. So a research software developer would generally be working on these kind of things, which are components that everyone else can use for enabling their own research. That's the broad sort of, or at least on the research side, this is what the hierarchy looks like. One thing to be careful of is the more senior you get, the expectation is that it would become harder and harder to distinguish between, for example, engineers and scientists, because you would be so good at your field. I mean, let's say there's this person who is very good at understanding, for example, how optimization works, but they could have gained this knowledge by, more in a scientist form or in an engineer form, in the sense that they would have trained a lot of systems and now they understand how to tweak these parameters. So at least in FAIR, the expectation is if you walk into a room and you talk to someone, you should not be able to distinguish between whether they are engineer or scientist if they are at a high level. So it's like there should not be a way to distinguish between them. They should have similar level of knowledge. Obviously, the kind of knowledge they would have is slightly different, but the level of knowledge should still be the same. So research scientists, research engineers, and research software developers. On the ML side, you would have the same thing. You would have ML scientists, ML engineers, ML software developers, ML developers. This is a very heavily overloaded term. What generally teams often use ML in the context of actual ML product work. So if you have an ML sort of a designation, that generally means that you're working with the products. You could still be working on very open-ended problems, and that doesn't mean you're taking someone's model and just tweaking it. You could be writing your own models. But the expectation is that the problems that you're working on are more well-defined, and there's a direct product impact from them. Now, the main difference between, for example, ML scientists and engineers would be in terms of, one big difference between when you're doing ML for products versus research is when you're doing ML for products, systems have to exist. If they do not already exist, you make them. And if they exist, then you use them. Whereas in research, I and you could be working on reinforcement learning problems, but you and I could have a code base which is totally incompatible, and we don't even know about each other's existence. So ML engineers or ML scientists would be working on top of a company-wide framework often, And ML engineers are the ones who would be, for example, let's say, adding new features to it. And by features, I literally mean features, like features for machine learning, not like system features. So they would be, for example, figuring out, hey, there's this feature. If we compute it this way and make it available as part of the training pipeline, then everyone else training their models on top of it could benefit. And ML scientists are the ones who would often be running those experiments and running those experiments in terms of setting up the hypothesis. Hey, if we do this, if we change XYZ in our ranking model, probably the engagement would increase or decrease and so on. So that's the hands-on side of it, in the sense that you describe the hypothesis, you design the experiment, you run it, you execute and see whether it makes sense or not. Whereas the ML engineers or ML software developers are the people who are enabling that by adding either machine learning features or system features to the underlying systems. Yeah, and from that perspective, ML scientists often also tends to be hands-on, because the differentiation is not so much as to, hey, am I just clicking a button to run an experiment? The differentiation is more like, hey, this feature already exists. This is how I want to transform this feature, and this is how I want to use it. This is what an ML scientist would be doing. An ML engineer would be more like, this feature does not exist in the first place. Let's figure out where to ingest it in the pipeline. Where does it come out, or where is it exposed to the other people who are using this feature? So that's the broad difference where they would be operating. But again, these are very heavy loaded terms. An ML scientist, an ML engineer could be doing the exact same thing, and it's fine, it's valid. So whenever you're applying to the companies, make sure you explicitly ask what exactly is your job duty going to be. Do not get attracted by the fancy titles. Understand what the job duty is going to be. And just to throw the third thing in the discussion, a lot of places, data scientists would be doing what ML scientists are supposed to do. And in a lot of other places, data scientists would really just be asked with, hey, this is what happened in the last 1 week on the website or the cards or so on, and figure out if there are interesting trends, right? So even a data scientist could have very different kind of analytical versus modeling work. So whenever you're applying, talk to the team, figure out what exactly do they do, and then decide. Don't go by the title. Titles can be very misleading here.
All right, but I think so. You've like the way you've explained us what roles, like as to what one's role is, like what the job description is for different roles. I find it very fascinating as to what type of projects you would be doing right now. Like, could you shed some light on what projects you are doing right now at Meta AI? And can you tell us like as to what does Meta AI do in general? So like both these questions.
Yeah, so Meta AI is basically a broad organization which is doing all things AI within Meta. So from that perspective, the machine learning models that you interact with knowingly or unknowingly when you're using any of the Meta services are being either enabled or owned by these teams. An obvious example is, for example, is ads and ranking and those kind of things. A somewhat non-obvious example is translation that you see on post. That's also, it's a machine learning system. No one is manually doing those translations. So that's the product side of it. And obviously a lot of other things that are happening on the Quest and the hardware devices that is also being increasingly enabled by machine learning workflows. Another aspect of things that we usually do not see, or we are not directly, we just do not come across it on a more explicit basis, is things like hate detection or taking down misinformation posts and so on. And we don't come across it because hopefully it has been taken down by this time. We could have come across it. So all this work is enabled by machine learning systems, and all of this comes under the purview of MetaAI. So this is like the product side of it. On the research side, there are some broad organizations. The main at least AI research org is called as FAIR, Fundamental AI Research. Used to be called as Facebook AI Research. The goal there is that work on problems that either push the frontier of science or cause some sort of a step function change. And an example of those step function change could be, I think just 2 days back, they released some new work around proteins. Sorry, I haven't followed up on all of it yet. There's some other work which is, I think this was around translation models where you can translate between speech without going through the language part first. So it's like speech to speech, let's say English to Mandarin or the other way around without actually going through the text route. So technology like this, which enables step function change. Other aspects of this would be, and a lot of times step function change doesn't happen, like, in some cases you could start with a problem and say, hey, there's this problem, we don't know how to solve it, let's work on it. The other way step function change happens is, hey, there's this broad open field, let's figure out what are the interesting problems and let's work on them, and hopefully we'll come across a problem that is important enough and interesting enough, which is more of the exploratory kind of research. So there's a lot of exploratory research work which also goes on. It doesn't become step function change immediately, but the hope is, when you're working on these exploratory problems, You'll figure out some important problems for the field, and then that would tell you what's the step, where's the step function change lying, and you would work on that. So I think that, and yes, the third part of this is open sourcing models, softwares, uh, enabling other people, I mean, people outside the company as well, to use and leverage these research artifacts. An example of that would be, I think, the OPT 175B model, which is basically a GPT 175B model, but that was open sourced, along with things like the logbook, which documents how this, what are the issues that the team ran into when they were training these models. Now, it is super valuable for people who are not training the system, and I'm not one of those people who trains the system, but to go through that logbook and to look at, these are the kind of challenges that people run into, that is super useful. It also gives you a sense of whether this is something that you want to do or not. So there would be issues like, I don't know, the cloud server is down, and now someone is trying to bring it up. And, hey, but I signed up for machine learning work. Why am I doing this? But you have to do this. And this gives you a holistic view of, look, training models may sound super awesome and super fun, but there are all these kind of problems that you run into. You would run into problems like, hey, I was training it on 64 GPUs, and one of the nodes is down, which means my entire training is stuck. So I have to kill the job, restart it, and have to make sure that the checkpoints are loaded correctly. And none of this it does not sound fun, right? So reading things like these logbooks gives you a perspective of, do you want to do this or not? And maybe you want to, that's great. But it's much better to know what you're signing up for upfront versus getting into the job and then realizing, there's all this not so fun work that I have to do as part of this training large models. So yeah, all of this works come within the MetaAI perspective.
All right. So, how is the work environment and culture at MetaAI? Like, what's your experience been like?
So broadly speaking, the culture is very bottoms up. People are encouraged to work on things that they find interesting and are and things that are important. The culture, so this means you can work on things where you see a gap in the knowledge, either in terms of research or production capabilities, and you work on it, and you can you basically don't have to worry about, hey, I need permission from all the way down before I can start working on something. So this empowers you. You are responsible. You are owning stuff. It's not that you wake up in the morning and you have an email telling you, hey, work on ABC this morning. Like, no, that's not how it generally works. So the general culture, and this is true for most of Facebook and most of Meta, and not just Meta AI, that the culture is very bottoms up. The culture is also very open in terms of, you easily know what other people are working on and what other teams are working on, and where potentially your work may be useful. So again, you have that ownership, you have those sort of resources to figure out where your work can become interesting and useful. Specifically in terms of the team that I work with, and this part is going to be very team specific, because some teams have, the way different teams operate, it's going to be different. At least in the exploratory research teams, it's generally very flexible. You are working on 2 or 3 projects at a time, and these projects can be in different degrees of completion, and there is no hard deadline in terms of, hey, you have to wrap this thing within, I don't know, next few weeks. But the way the process goes is, you are evaluating things for yourself, and your collaborators are doing this for you. So you're working on something, let's say it's been N months, and you do not see, you're not making any progress. So at that point, you could decide, hey, I'm going to pivot a bit, because we are trying a research direction, it's not working out. We tried reasonably well, and it's okay. So you can do the pivot, and you can decide those things on your own. In some other cases, you could decide that, hey, there's this direction, I'm super fascinated by it, and I'm going to devote 100% of my time on this thing. And again, you're fully supported to do that. So the day-to-day execution decisions and somewhat longer planning in terms of, hey, this is where I want to be, and this is the kind of problems that I want to be working on, this is pretty much driven by you. Even the collaborations are very bottoms up, which means in a lot of cases, you cannot go to someone and say, hey, work with me. It's more like, hey, I have this interesting problem, and you have this expertise. I think your expertise is going to be useful in this aspect, or hey, I have this problem and I know you are interested in this problem as well. Do you want to figure out a way for us to work together? Which is, sometimes it's fun, sometimes it's annoying, because you really have to, it's like you're pitching your problem to a lot of people, and you're trying to make sure they are also excited by it. So in that sense, it could feel a bit like, setting up a collaboration the way you do it in academia. But it's also fun, because this means that the problem gets vetted a lot more. It's not like, hey, I'm telling you work on this and you start working on it. Probably you do not fully buy into the problem. Probably you see some issues with the approach. So we iron that out. And it's also good because this means no one can come to me and tell me to work on something, because it's like, hey, but I don't find it interesting, or I think the approach that you're taking is not very reasonable. So it works both ways. You cannot force someone to work with but at the same time, this means you are not sort of forced to work with someone. It's a very bottoms-up culture, and people are empowered to figure out what things they want to work on and how those things fit into the bigger plans.
All right, so that's a fantastic culture. I feel that going up, bottoms up, and you having the flexibility to do all right. You're your own boss to some extent there too. So, how's the growth of MLDL in today's world with the job and the career point of view? And do you think the demand for the same will keep increasing? Like, what is your point of view?
Yeah, I mean, I think of these things on a longer time horizon. And by longer time horizon, I mean probably in terms of decades. I think the perfect time to get into MLDL was probably 2012, 2013, getting started rather. I mean, like for a person who does not know anything about DLML, 2012, 2013 was probably a great time to get started. If you're getting started into MLDL right now, there's still a lot of opportunities, but probably not as much opportunities as there were earlier. And it's a normal thing. Look, we live in a technological world, and technologies come and go, and there are cycles. Certain technologies are more important at certain points of time, and then their growth starts to deaccelerate, and that's a very normal thing. I mean, I'm not worried in the sense that, oh my God, AI ML is probably becoming less important. No, it's just that the rate at which it was becoming important for the last 10 years, that rate is slowing down. It's obviously still becoming more important. There's still a lot of things that people haven't figured out. But I don't think it's growing at the same pace as it was growing earlier. And that's also because when there's a new area, people don't understand what to do with it, right? So there's like, hey, let's try this and let's try that. And there are basically a lot of things that you can do. And over time, the field starts to mature. And you start figuring out what are the important problems. To take an example, database research, right? People still do database research, and it's obviously a useful and important area to work on. But database research probably does not get, or compilers research probably does not get the same level of excitement that AI ML research gets. Why? I mean, are they not important? They are. It's just that they are more mature than, for example, AI ML research. And that's what happens with most fields. They mature out, which is a good thing. It's important that fields mature out, because if they don't mature out, it's like, hey, it's been 20 years, we are doing the research, and we still haven't agreed on what are the most important problems for the field to work on. So we are starting to see some signs of maturing, again, which is a good thing. We should not think of it as a bad thing. Field is maturing. We are converging on some important problems that the committee should be working on. And whenever that happens, it's a normal thing that the hype starts to go down a little bit. And whatever is the new thing that would come up and pick up, that would get more hype. I think the fallacy is to equate hype with, for example, hey, I want to work on something because it is in hype. Like, that's the fallacy. Things would go in and out of hype, and that's perfectly okay. People should figure out what are they excited about, and they should work on those things instead of saying, hey, I want to work on AI ML because it is in hype.
All right. So, what according to you is the thing which, like, what according to you is the best thing that you should be doing in 22, 23? Like, for example, you said 2012, 2013 was the best time to start or get into DMLDL. All right. But what according to you is the current thing which might go into hype?
I mean, this is always a bet, right? If I would have told you in 2012, hey, MLDL is the only thing that you should be working on, you would probably not have bought this argument.
100%. 100%.
So it's a bet, and people have to, and I mean bet not in the sense of, hey, you're gambling, but I mean in the sense of you have to take certain positions in your for your career. And you took a position by choosing IIT Roorkee, right?
Right.
And by taking IIT Roorkee, you let go of a lot of other opportunities. And the same thing has to be, and I don't know whether IIT Roorkee would be famous in 10 years. Maybe it would be. I hope it would be. Maybe it would not be. Bad bet, right? So just the way you decided to be in Roorkee for doing your undergrad, and you decide other points in your career, right? People have to take a call on, hey, this is what I want in life, and it keeps going back to this thing. Hey, this is what I want in life, and this is the level of risk that I'm willing to take. Now, if you're saying, hey, I just want a peaceful life, I'm not a very risk-taking person, and it's perfectly fine to be one of those people, then just stick with AI ML, right? It's a safe field. It's not going anywhere in the next 10, 15 years. And when I say that it's maturing, again, it's not that it's declining. I think the speed at which it was growing is slowing down, and that happens whenever the field starts to mature. So AI ML is still a pretty safe bet, and there's nothing wrong with that. Keep doing that. That's awesome. That's great. If you're being more adventurous, I don't know. I mean, by no means am I endorsing any of these areas, but maybe quantum is one area to be in. I don't know too much about it. I've just heard nice things. And again, by no means take it as an endorsement.
Right.
I do not.
Right. 100%.
And then there are other cool things that seems to be coming up. Again, I don't know how meaningful they are or what kind of do you want to be working on something which is super chaotic? Maybe machine learning was somewhat chaotic in 2015, 2016. Sometimes it feels still chaotic, right? Like so many things happening and still not super clear. But if you're starting to do your PhD now, and by the time you'll graduate, probably a lot of chaos would be gone. And it's much easier to create an impact when things are new. It's much easier to sort of cement your position when things are new versus, hey, now everyone knows who the leaders are and everyone knows who the experts are. And then it becomes a bit more difficult to find your place, right? So if someone was to do a PhD in AI ML right now, it's still a super safe option, but would it still be, would there still be scope for making same level of impact 5 years from now? I don't know. Transformer came out in 2017. It's been 5 years. That probably gives you a sort of sense of how many people have already adopted transformers. But at the same time, things like LSTMs are completely gone or not used that often. So if someone was focusing or super focusing on just LSTMs, then probably they took a bad bet. But if someone was super focusing on transformers, they took a super good bet.
Right.
Yeah. So again, I'll probably, instead of saying what people should work on, they should figure out, or they should think more deeply about what kind of work do they want to do. For me, the rough rule of thumb is I want to build my muscle, and my muscle is in things like thinking about systems, thinking about how programs should be written. And this is devoid of any language. Like I don't care whether I'm using Rust or Python. I want to think about systems. I want to think about how to build systems. I want to think about how to start with a big problem, break it down into smaller pieces. And probably for one of the smaller pieces, the answer is AI/ML. And that's great. Like, sure, we'll fix it using AI/ML. Maybe for some other piece, the answer is, I don't know, quantum. So, okay, we'll figure out what the solution in quantum is, and I'll do that. Obviously, my answer is super biased, and it's biased because the first set of smart engineers that I started working with were at Adobe, and these were the people who had no experience in data science ML. They knew how to think about problems. They had a clear way of breaking down problems, and they were trying to build something which they had absolutely zero experience in. And to some extent, I feel they were being successful. And so the skill that I invest in is start with something vague, make concrete pieces out of it, and work on those concrete chunks and concrete blocks instead of being super worried about, hey, what is the solution that I'm using for every single block?
All right, interesting. My follow-up question to you would be, how can one crack DLML jobs, like while in India, how can I crack DLML jobs abroad? Like, is there something like, all right, getting a master's is one option, but other than that, is there any way for students in India to get jobs abroad?
I mean, if we ignore the current market situations where there are, the number of jobs is declining across the tech industry, if we ignore that aspect for a minute, I think the broad question is, how are you going to show me that you know your DLML? One of the problems that happens when a field becomes democratized is that it becomes democratized. I don't know if you have ever written an optimizer by hand, or I don't know if you've even heard of things like Cafe, which used to be the thing earlier. I mean, I'm all for democratization, but the problem is now everyone can take PyTorch or Keras or JAX and start training models, which is super good. But at the same time, it becomes difficult for you to stand out, or for a person to stand out. They cannot just claim, hey, I know how to train machine learning model. Hey, everyone else in the world knows that as well. So then the question is, and this applies not just for jobs abroad, this applies for jobs in India as well. How do you stand out from the participants or everyone else who is applying for the same position? Part of it goes back to the conversation we had earlier about research papers. That writing research papers is a way of showing those particular skills. There are other ways of showing those particular skills. Can you maybe you have done a good analysis on some kind or some family of models, and you have some blog post or some collab notebooks or some other way of showing that you have done that analysis beyond just saying, hey, I have done that analysis. So maybe you have some work to show for that. And this is where things like collab have actually made everyone's life easier, right? Like in our time, when we were in undergrad, we did not have any way of training these systems. And it's not that collab is absolutely free or it's super accessible for everyone, but definitely the barrier to entry has lowered a bit. Yeah, I know this is not like a super concrete suggestion or something, but really the high level argument is that you need to have a way to show that you know your stuff. And just saying, hey, I know how to do DLML, it's not going to cut it because everyone knows how to do DLML. And the ways you can stand out is maybe you have some open source projects which have been used or which people like, and then you can argue that, look, I've written this library which is open sourced and it's on GitHub and people can check it out. Maybe you've written a lot of blog posts. Maybe you have written some sort of papers where you have clearly documented that you understand what you're trying to do, but there has to be some way you show it, and that some way is going to be different for different people.
All right. So standing out is something that you need to do across all spheres, and that is something that you need to do to get jobs abroad too. All right. So I was reviewing your blog post on Medium where you summarized research papers weekly back in 2015, which is a great move to keep yourself accountable for doing that particular task and sharing knowledge at the same point in time. Do you have any other such academic tips that you follow or something that you think our podcast viewers might like find helpful, especially the second, third, fourth, and the fifth year students currently pursuing their B.Tech?
Yeah, I think one advice I'll give you is have some sort of a board of directors or a board of people who is going to hold you accountable. And I don't mean it in a formal sense. Like I'm not saying have a board meeting every few months, right? I'm just saying there are people who know that I'm trying to achieve certain things, and their job is to keep me accountable. And the way they keep me accountable is when I talk with them, or every once in a while, they'll make sure they ping me and they ask me about, hey, how much progress have you made on certain things? And it's not just accountability; they are also helping you. uh, at least for me, most of these people are people who are my contemporaries, right? So they are also helping you to get out of your bubble. I mean, we think we want X, and then we start taking a path and we start working towards that. And sometimes that means that there could be another path and we just don't look at it. But when other people know about what you're trying to do, they can help you figure out, hey, you know what, there's this other way that you can reach the same thing, because sometimes we equate the goal with the journey. And I see this question very often. People would be like, hey, I want to work in US. What PhD program should I sign up for? Dude, you want to work in US. Where did the PhD come in, right? Like you decided that you need a PhD to work in. So this we all do this. And very often we think we want X and Y is the only way to get that. So have people who are going to hold you accountable. Obviously, this means you're going to be vulnerable in front of them. You're going to tell them, hey, this is what I want to do. And these are the reasons I might fail. And sometimes accepting that it's difficult to tell someone, look, this is what I want to do and this is why I feel unqualified for that thing is difficult. And that's why you want people who you trust, who you can be sort of honest about about how you are doing things, or if you are being successful or not, or if you are being a failure. So, but yeah, important thing is you have the set of people with whom you could be open and you can tell, look, this is what I want, this is how I'm thinking of going about. If you have any suggestions, let me know, and please help me hold accountable for these things. And that works great.
All right. Is there any piece of advice you would give to the freshers who just joined IIT Roorkee this year, like to take full advantage of their college life, like be it exploration of their own personal life, be it academically, career wise? Or like, what is your advice to the freshers?
Number one advice is make as many mistakes as you can. I mean, not mistakes which hurt people, but mistakes in terms of, hey, this looks exciting. This area looks exciting. I don't know whether I would enjoy it or not. And, if I work on it for a couple of months and I don't enjoy it, I have wasted that time. Yes, make those kind of mistakes in terms of wasting your time, because it's important to get a flavor of what are the things that you can be working on, what are the possibilities that you can be working on. So that's number one advice. And don't really think of it as failure. I'm calling it a failure so that you don't to normalize it basically. But obviously it's not a failure. It's important that you try things that you think you might be interested in, and it's perfectly okay for you to sort of abandon them if they do not seem to be interesting to you. So it's like, hey, you start reading a book and you don't enjoy it, that doesn't mean you have to finish the book. You can just keep the book aside and move on. It's okay. So don't be super hard on yourself and try out a lot of things. And try out a lot of things does not just mean try out academic things, or it just does not mean try out, I don't know, different courses. It also means things like, I don't know, you want to try running early morning? Great, try it. You want to, I don't know, go to the gym? Great. You want to learn swimming? Great. I learned how to ride a bicycle in college. I did not know how to ride a bicycle.
Wow.
Yeah, I mean, I was a lazy person. Point is, if I had not done it then, and if now I was to go to someone and be like, hey, can you help me how to learn to ride a bicycle? I mean, it's going to be a lot more awkward now as compared to then, right?
Right.
Uh, and invest in relationships, make friends, and make time for people. The biggest thing that I miss about Roorkee is the kind of relationships I had with people. You could be so carefree. You could open up, and it's not just you who's opening up. Everyone else can open up. You can go to anyone's room at any point, and yeah, I mean that was a perfect thing. And the friends that I have from Roorkee, they are they are basically the best friends that I have in life. And it's been what, 5-7 years. It's just difficult to make that kind of friends again, because you are physically in the same space. You are actually seeing each other going through good and bad. it's not like someone needs to call you and tell you, hey, I'm having a good day or bad day. You experience those things with them. So the kind of relationships you form, the kind of friendship you form, it's very difficult to form that again later in life. I mean, maybe if you're lucky, why not? Uh, Most of the time it's very difficult. So invest in that, invest in your friends, make time for them, do crazy things with them. It's not just about grades. It's not just about, I don't know, check marking items. Do crazy things with them, even if those things are somewhat uncomfortable for you. It's okay. It's like, you're trying it, maybe you like it, maybe you don't. And don't be too hard on yourself. Yeah, enjoy.
I think those are some great tips that our freshers should obviously take note of. And let's take you back to your college days now that this has come up. Can you share your best memory from college?
Yeah,
Any
so many.
fun trip or anything of that sort, which whatever you've done with your friends, anything fun?
Yeah, I mean, some of those things may not be appropriate for the recording. Uh, yeah, I think a lot of those things won't be appropriate for the recording. I think the important thing that comes out is we like to think that we are special, right? Like, hey, I'm the one who has cracked JEE, or I'm the one who has, I don't know, I'm the only one who can write this program, or I'm the only one who can solve this problem. It's important to get rid of that attitude. Yes, you could be great at what you're doing, but that's it. That's where it stops. It doesn't mean others cannot be great at it. And campus life shows you that, right? Like, no matter how smart you are, no matter how good you are, you do look around and you find people who are excelling in their own specific areas, and that's awesome. So in that sense, it helps you build character as well. It helps you to be proud of yourself without sort of, it's like you're drawing two lines, and for your line to be bigger, the other line doesn't have to be smaller, right? So it helps you appreciate that. uh is there any specific thing that I can share? Yeah, I mean, this is about me, so I can probably share that. In the first year, I had a course. I wouldn't name that course, and I honestly felt that I'm going to fail that course. And I had some miserable days because of that. But the good part that came out was, and yes, I did not fail the course, but the good part that came out was, for the rest 7 semesters, I at least wasn't worried about failing anything. I was like, sure, we'll manage everything. And that's good, because whenever the first time you fear about failing a subject, it would happen at some point or the other. And whenever it happens for the first time, it's going to be scary. But the later it happens, the more difficult it's going to be. It's going to handle it. I talked about this paper which was test rejected. Is if a paper of mine was test rejected today for the first time, I would have a lot more questions about me. It's like, oh my God, I mean, you have been doing it for so many years and you wrote a paper that got test rejected. Versus something that happened then, and then it sort of normalizes a lot of other experiences for you. Sometimes you get very stupid rejections, and you're like, it's okay. I mean, you once got a desk reject, right? It's not worse than that. So yeah, that's the power of sort of negative experiences. They make a lot of other things positive. So try to do things even if you think you're gonna terribly fail. It is going to be helpful. Yeah, and I was very lucky with that experience in the first semester, knowing that I might actually fail that exam, made the rest of the 7 semesters very, very comfortable for me, because like, look, I know I'm not doing that terrible in this subject. And there was this subject where I felt I was doing terrible and I still got through. So, everything else can be managed. Yeah.
All right. I thank you so much, Shagun, for sparing your time, talking to us, and giving us so much knowledge. I'm sure our audience would have had a lot of takeaways from this conversation of ours, and that they'll excel in their own journeys. I wish you the
Yeah.
best of luck in all of your future endeavors.
Thank you. Thank you very much for having me. And I'm super happy to see more campus groups coming up. If anyone has more questions, you can email it to me. I might be a bit slow in replying, but I'll definitely try to reply. And do mention that you're emailing from IIT Roorkee.
Sure. Thank you so much, Shagun.